So we have this recent work, title's a little bit long. It's called the impact of task under specification in evaluating deep reinforcement learning. This was actually a really fun work, and this actually is a little bit indicative of my style of research, where we start with a practical problem, and I love it when it sort of reveals a more common problem than our application. So this goes back to the curse of variety. We basically thought, okay, let's apply standard deep reinforcement learning methodology to control traffic signals for a variety of intersections. We were modeling traffic signals. We were modeling traffic intersections from Salt Lake City in Utah in collaboration with Utah Department of Transportation. And we found that, unfortunately, and also to our surprise, the existing methods, the existing deep reinforcement learning methods for traffic signal control, even though in previous papers they reported outperforming our classic control strategies, the fixed time control, the things that you see, adaptive, actually mostly fixed time control. In our study, when we considered this sort of broader set, this with more variation in traffic intersections, that was no longer the case. The algorithms no longer did as well. And this was, even if we say trained on this set, I should clarify. So it wasn't just taking that work and generalizing it to this set. We were actually training on this set of intersections, and the algorithms themselves were not robust to this broader set of intersections. In our case, we found that the classic currently implemented strategies outperform these learning-based approaches. This highlighted, this in some sense can be thought of as a negative result for machine learning, but for us, it actually pointed out an issue in how we evaluate machine learning methods. Okay, because we previously concluded they are better, but when we evaluate them slightly differently with a broader set of what we think of as a traffic intersection, that was no longer the case. So this is what we call task under specification, where if we think of an intersection as, say, one thing or 5 things, where in actuality it's 1,000 things, or maybe even more, 10,000 things. If we evaluate them, if we train them and evaluate them only on a few instances of what a traffic intersection is, we might draw the wrong conclusion. And we found this to not only be the case for traffic signal control, but when we went back to sort of standard benchmarks that the community relies on for evaluating machine learning, reinforcement learning methods, we found a similar conclusion. And so in this work, we sort of reveal the problem, and we also reveal how hard it is to solve. And we have some ideas on how to overcome it, but it's actually been amazing to engage with the community and sort of highlight this. We've had a lot of folks from industry who are applying reinforcement learning, and they have come to us saying, thank you for justifying what I'm seeing in my own experience using reinforcement learning. And we've had other reinforcement learning researchers engage in conversations on how to start addressing this challenge.